Let's get down to answering that question of factoring completely. I have left that integral zero theorem up there. If x minus a is a factor of p of x, then a is a factor of the constant term p of x. In other words, this is how I get started. I'm testing out how can I identify all my possible factors of this polynomial. By the way, this is p of x. So here, to identify the possible factors of this, I am going to take I'm going to take my constant term, and my constant term is -2. My factors of -2 are going to be -1, 1. I'm going to try to switch colors for every one now. My apologies. -1, 1, -2, and I'm going to say +2. Now, each of these corresponds to the factor x minus a. So -1 corresponds to the factor x plus 1. 1 corresponds to the factor x minus 1. -2 corresponds with the factor x plus 2. And when a is 2, that corresponds to the factor x minus 2. So which one of these are factors of this? That's a great question. I will let you in on the secret. I think you should always do the easiest one first. Why? I think math teachers generally recognize that math can be hard, and what they want to do is they want to test your knowledge. They don't want to put you through tedium. So generally they give you an easy out by, not generally, but so often they give you an easy out. So I'm going to use the factor theorem. So I'm going to test the factor x minus a, or x minus 1. I'm going to put the f of 1. Does the f of 1 equal 0? Well, let me check. Oh, sorry, it's the p, not the f. So it's 1 to the power 4. All I'm doing is plugging in 1s for my x values. And the interesting thing about where x is equal to 1 is that when x is equal to 1, it's just really the sum of the coefficients. So it makes it really easy. So 1, this ends up being 1, plus 3, plus 1. So that's 5, minus 3, minus 2. Look at that. So the p of 1 is equal to 0. So therefore, x minus 1 is a factor. So I found one factor. That's great news. So what do I do about this? Oh, yikes. Yikes. Where am I? Ah, there we are. My apologies. What do I do about this now? Well, I simply take that factor and I divide it into my polynomial. So now I do x minus 1 goes into that big beast of a polynomial. Now this probably will not be very much fun. All right, do it. We learned long division, but me, personally, I like to take the easy way out. Who doesn't like synthetic division? Okay. So do synthetic division. I'll press pause here. Let's see if we come up with the same results. All right, we did synthetic division. It was fun, I'm not going to lie to you. This was my result. From this result, I know that this is my remainder. This is my constant term of my quotient. This is the x to the power of 1, or my x term. This is the x squared term. This is my x cubed term. So the quotient of this division is 1x cubed plus 4x squared plus 5x plus 2. So in other words, I can take this big long polynomial and I broke it up into x minus 1 times this cubic polynomial. All right, here's your next task. Now this is ending up pretty long. I wonder, here we are, I think that this is prime. I can't imagine two quantities multiplied together to give me x minus 1. I'm going to suspect that this is non-prime. That is, it's a composite number, that we probably multiplied some factors together to give us this polynomial. Which of those are the factors? Great question. I'm going to ask you to find some factors, very similar to what we've done here. I'll press pause and I'll send you on your way. All right, let's go, team. Spoiler alert, the P of 1, when I substitute, sorry, I got ahead here. I'm going to use the integral zero theorem here. The factors of 2, so I look at my constant 2. The factors of 2 are negative 1, positive 1, negative 2, positive 2. And then I simply plug those into my polynomial, into the blue one, to see which ones I'm going to effectively use the factor theorem. So I notice that the P of 1 does not equal to 0. So therefore, it has a remainder. And I likely, I'm getting distracted. So the P of 1 is not equal to 0, so I can conclude that x minus 1 is not a factor. However, the P of 1 is equal to 0. So what does this mean? This implies that x plus 1 is a factor. So now I'm going to take x plus 1 and I'm going to divide it into that. And I'm going to press pause here, I hope, and you can do it as well. So press pause and take a few moments and let's try long division, see if it works out. All right, so I did my long division and believe it or not, I'm almost done. So I'm just going to say P of x. P of x, well, here is going to be the green. Well, we start off with the factor x minus 1. And then this is the blue polynomial in which we use the integral zero theorem and then the factor theorem. And then we used long division and we broke up the blue polynomial into x plus 1. And it was x squared plus 3x plus 2. And remember that this is factored completely. And believe it or not, we're almost there. Now think, factor completely. Well, if you notice, the last polynomial over here, the polynomial factor, like x minus 1 is definitely prime. X plus 1 is definitely prime. Now, I can envision that since this is degree 2, this might have two factors. I wonder how I could factor this. Synthetic division? Long division? Well, how about you just factor this using your grade 9 and 10 skills? Well, since my coefficient is 1, I get to use the sum and product property, the factor, and that's what we have here. So I can factor x squared plus 3x plus 2 into x plus 1 and x plus 2. In other words, this polynomial P of x, I can rewrite this as, no, the above is correct, but alternatively, I can write it like so. All right, I hope this helps. If you have any questions, feel free to ask by all means. Good luck, and we'll see you very shortly.